And welcome everybody to the Daily Space Weather. Today we're talking about a coronal mass ejection that we've sighted. We'll show you details as well as some chaos in the Van Allen belts, coronal holes, and more. First we're looking at the sun. It's 304 angstroms ionized helium from the Solar Dynamics Observatory. If you put your attention up here in the northeastern limb near my pointer, you may see a rather high-speed coronal mass ejection happen right there. It's pretty tough to catch. It was pretty quick. We'll tell you about the telemetry as we look at the viewpoint from Lagrange point 5. So stereo A is out here at Lagrange point 5, trailing the Earth orbitally speaking. And if you look at the left pane here, you can see this coronal mass ejection, which started around 1800 hours yesterday on 6/10, June 10th. And for you new viewers out there, the Earth would be off to the right on this imagery here. The Earth is off in this direction from the perspective of stereo A. So let's just go back to this diagram again. Again, stereo A located out there. And let's take a look at it from the SOHO coronagraph. And you can see how deceptive this coronal mass ejection is, in that it looks like it's sort of could be a little bit on the Earth-facing vicinity. You can see it coming out here on the LASCO C3 coronagraph. But indeed, it is on the opposite side of the sun only. There is still an ongoing possibility for additional coronal mass ejections. We'll keep you posted. Here's some more imagery from the SDO. This is 131 angstroms and 94 angstroms, two different ionized states of hot gaseous iron in the sun's atmosphere. And here's one more set of images from the Solar Dynamics Observatory in 193 angstroms, some highly defined coronal holes associated with the South Polar region. Also, we saw a shift in the BT/BZ cause immediate geomagnetic effects. Some odd ground perturbations we're going to show you a little later in the video. Also, first, here's a diagram of the solar system. We'll advance this 1 week. And there's where things will be in 1 week. Next, a star chart. If you're up before dawn, you may see Jupiter and Saturn on the ecliptic, which is this yellow line we've drawn in, the path which the sun would take across the sky. The 10.7 centimeter radio flux, the most proportional data set to sunspot number, is at 79 solar flux units. Here's the 1-year chart of it from Solon.info. The black line is the radio flux, the red line is the sunspot number. We don't see any geomagnetic storms forecasted here, although we should expect some activity perhaps late on the 13th, early on the 14th from those South Pole-oriented coronal holes. Let's take a look at global seismicity. We see some oddities in the earthquake list. So there's the bar graph of the past 90 days. And we saw only 2 5+ magnitude quakes, one of them in a strange spot here in sort of Central Africa and Congo, near Lake Tanganyika. And the other, the largest of the past 24, was this 5.7 off the coast of Costa Rica. Let's scroll up the list here on U.S. Geologic Survey. This one's pretty weird, too. This one very far north in Canada here, near Saluit, Canada. A 4.6 magnitude. Up in northeastern Canada, a strange place for a quake. China also saw a 5.1 magnitude. Very deep quake in Argentina at over 570 kilometers estimated depth. So here's this Costa Rican quake, the largest of the past 24, a 5.7 magnitude, off of the coast of Central America. There's the location of that. And let's go back to the list. Looks like there was also a 5.5 at Indonesia. That must be the second largest quake of the day. Of the past 24, I should say. Papua New Guinea also saw a 5.1. And Taiwan, the country of Taiwan, also saw a 5.2. Please leave us a comment if you think that was a controversial statement. Next, volcanoes. We've got some fantastic footage of Fagradalsfjall, the Icelandic volcano, which filled up its crater valley and became a shield volcano. We watched it evolve from a cinder cone to a shield volcano on the Reykjanes Peninsula on Iceland. Volcano Discovery's friend Ronnie from Belgium just returned from Iceland. Here's a small selection of the video that he took. And it is quite spectacular. Again, you can link to this on volcanodiscovery.com in their Volcanoes Today section. Spectacular imagery here from Fagradalsfjall. Here's a great lava flow in the daytime. Absolutely spectacular eruption from Fagradalsfjall in Iceland. Abiko is also erupting. It's producing a 14,000-foot ash plume. Subanose-jima exploded. Volcanic ash cloud of unknown size. Luatolo now back on the list, as it produces a 6,000-foot plume of volcanic ash over the Lesser Sunda Islands, Semeru on East Java. 13,000-foot ash plume there. Sangay in Ecuador. 20,000-foot ash plume produced as it explodes. Revenador exploding in Ecuador. 19,000-foot ash plume there. Sabancaya also exploding. 24,000-foot ash plume. A great reminder to not pole vault the caldera. Please don't pole vault the caldera. It could be unhealthful, and we need the views on YouTube. So make sure you tell your friends and foes about the channel and about smashomash.com. Let's get back to solar data. One C-class flare in the past 24 hours. The peak flux there was at 6:30 Universal Time yesterday. Since then, fairly calm conditions in terms of solar flares, and we've seen this minor proton event now subside. There's the proton flux over the past 3 days. And we see very weak readings here in the GOES magnetometer. It all has to do with the shift in the BTBZ. We'll show you the data on that momentarily. First, some information about the heliospheric current sheet. Here it is in polarity, North Pole oriented polarity in green, South Pole in red. And the Earth is getting ready to reach another boundary crossing here as a North Pole current sheet is approaching. Maybe more quickly than expected. We'll keep an eye on it. Here's a line of sight ecliptic plane field plot. It's the same data, but it also shows you the solar magnetogram. And you can see this dipping of this blue line to the south. I would say that's going to go back to the north here in a moment. But in any case, there's the data. This is 1 hour and 40 minutes old when we made the video. Keep in mind the magnetic environment can suddenly change. Lastly, the line of sight coronal hole plot. I would direct your attention to the southern hemisphere. This fairly well-defined, nearly equatorial coronal hole associated with the South Pole shown in red. It also shows you the sun's B field in blue. And let's show a close-up of that South Pole-oriented coronal hole system in 193 angstroms. A great close-up of that South Pole-oriented coronal hole system. There's a stream of protons coming out of that as gas in the intercalate regions between liquid metallic hydrogen lattice layers is released. Intercalate gases could be responsible for the behavior of coronal holes. It's a plausible explanation of the sun's behavior. The liquid metallic hydrogen theory as a solar building block. Next, looking at filaments and sunspot groups, I would just remind our viewers that there are filaments that are not being detected here. You can see some down in this area, these dark areas, those are filaments. And there are also one very clear filament right up here. The likelihood for a coronal mass ejection is still there, despite seeing some pretty weak sunspot activity. So these sunspots 2829 and 2832 are looking very small. They could actually lose their names today, as there are barely even any umbrae visible. We'll show you the high-resolution imagery toward the end of the video. KP index currently at 3, and we saw this increase in geomagnetism. The KP index is a measurement of global geomagnetism, by the way, for you new viewers, and thanks for tuning in. KP3, so looking at the real-time solar wind, and we see this is responsible. What's responsible for this is this sudden shift in the BTBZ. So right around midnight, we saw the BTBZ, the total field increased to about 8 nanotesla, and the BZ, which is the orientation toward one of the solar poles, went down to -7. So that's highly South Pole oriented BZ, which affects Earth's geomagnetism, plain and simple. It creates additional magnetic perturbation on the planet, and it's a known thing. It's been a known thing for ages. Current conditions are just under 10 protons per cubic centimeter for the solar wind density. Solar wind speed quite low at 337 kilometers per second, and that's still enough to produce some significant ground magnetic perturbations. So this is supposed to be 4 hours of geospace magnetosphere movie, and it looks a little bit stalled there. Something's looking a little funky with the data. Not exactly sure what's going on with that. That's a bit of an oddity there. And we see most of the magnetohydrodynamic pressure in nanopascals showing up here on the non-sun-facing side of the planet. And that has to do with that extremely slow solar wind speed, currently under 340 kilometers per second. And the second half of the magnetosphere movie here looking a little bit more normal. And you're looking at two 90-degree twists of the planet, one from the equatorial plane, one from the meridional plane, as if you're viewing the planet from the side. Next, ground magnetic perturbations, our other geospace magnetosphere movie for the day, and you can see significant perturbations here. Polar regions, as well as coming out of some oceans here, like the Indian Ocean especially. Significant magnetic perturbations here on the ground as we live through a polar excursion, a geomagnetic polar excursion, folks. The North Pole has split into two. We have a North Pole over Canada and another one over Siberia, which is a little stronger. And the South Pole has left the Antarctic continent entirely and is someplace south of Australia. What will happen next? Do you have a theory? Leave us a comment. Let us know what you think is going on with the geomagnetic excursion. And check out those ground magnetic perturbations spawned by that sudden shift in the BTBZ, the magnetic field, strength and orientation of the closest star. Next, we're going to stream live for our cosmology segment. Make sure you check that out. It'll be a separate video today, not included in the daily space weather. And we just did our cosmology segment, which is a separate video today. Make sure you check that out. Next, looking at electrons, the Earth is surrounded by them. They give us insight into the Earth's magnetic fields. They do have the capability to charge up satellites. We don't really see much of that going on now. A little bit in Central America, the Western Caribbean, and the Central Pacific. Also Mexico, seeing some minor charging hazards. Here's the one-year chart of the electron flux. Those electrons are moving at very high speeds, giving them a very high voltage, like 2 million electron volts. Anyway, there's the one-year chart from Solon.info. Here's the 3-day chart. We're seeing low levels of electron flux, and we're seeing incoherent bands. Here's the forecast model. There's the lack of charging hazards. There's the one-year graph. There's the 3-day chart, and there's the forecast model. So I would say there's going to be an increase in the electron flux here. I would tend to disagree with this green box. I think we're going to see a little higher levels tomorrow. let us know in the comments what you think about the electron content forecast. So here's the total electron content forecast. This is showing you the entire air column. And this does a good job of showing you where GPS errors would be likely to happen. And we're seeing incoherent bands here. Look at these incoherent bands of electrons happening at nighttime. And that's typically what we see with low levels of electron flux. We'll let this play through a second time here. This shows you the entire air column of electron density from your GPS satellite to your handset, giving you the most likely areas for errors. Major nighttime errors happening here over Africa and the Atlantic Ocean. Continuing on, here's a diagram of the Van Allen belts. Feel free to pause the video. Distance is shown in miles. Here's another diagram of the atmospheric distance is shown in kilometers. And the relevant one here is the F ionosphere layer, which is our next frame. So here's an animation of the F ionosphere layer, and it's looking a little bit anomalous here at times. We're seeing large, low-frequency sections here at nighttime, and we typically do see this associated with low levels of electron flux. So not really a big surprise to our regular viewers there. So there could be some very weak radio propagation in the southern hemisphere associated with these red blobs where the F layer evaporates. The F2 layer becomes an F layer. Anyway, each one of these blobs represents 1 megahertz, 1 million cycles per second of vibrational frequency at the bridge between space and Earth at the F ionosphere layer. Here's the latest image coming through at 9:15 Universal Time. Things looking pretty normal at that moment. Next, we're going to do a meteorology segment. By the way, it will be a separate video from the daily space weather, so make sure you check that out as well. If you haven't, we'll invite Twitch. And we just did our meteorology segment. Make sure you check that out. If you haven't, let's get back to the daily space weather. And we forgot to show the dust apocalypse. You can see dust here stretching all the way from the Sahara Desert to Cuba, making its way into the Gulf of Mexico, actually. We meant to include it in the meteorology segment, but we forgot, so it's part of the daily space weather video instead. Here's the rest of our bonus features. How about Udaipur, India's ground-based solar observatory? Nothing too exciting going on here, I don't think. Again, keep in mind, folks, there are significant filaments on the sun. We could see additional coronal mass ejections. We'll be keeping you posted on that. And here comes some more bonus features. It is the intensitygram to show you the latest on these two sunspots, which are losing their spottiness. That's now an alpha-class sunspot, and that's on its way to losing its name as well. Here's the colorized magnetogram. We'll make sure that's refreshed. And that rising active region down there in the southeast is not a sunspot either. So we've got two sunspots. They're both evaporating. Solar activity is dropping. And here's some more imagery. It's the composite 131 and 94 angstroms. The lovely turquoise colors of that. And we'll close things out in the northern hemisphere here in 304 angstroms. You see this sudden coronal mass ejection, filamentary eruption and prominence happen here, right over here. And it's so fast you pretty much blink and you'll miss it. Also, don't forget to join us for our solstice stream when that happens in about 9 days. Thanks to our patrons, a true source of funding for the content. Consider becoming a patron if you want all the first alerts and all kinds of other multimedia and other perks. Patreon.com/smashamash. Thanks again, patrons. And we'll close out the video with this view of the northern hemisphere. Thanks again for tuning in, folks. Remember to stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back. And I think I may have forgotten to include some slides here, so here's the imagery that we missed. Thanks again, patrons. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network. Least busted name in news.